just right, and it was all a matter of filling the details until quantum mechanics came along and changed things. In classical mechanics, an electron is a point. It has a position, a location in space, and it has a velocity. It's moving somewhere, and from that you can predict what's going to happen. Okay? Quantum mechanics says, no. The electron has a wave function. So if there's a wave, sometimes you hear this debate about are things like electrons and photons particles or waves. The answer is that they are waves. And the wave function has this weird property that when you're not looking at it, it's a wave, it's all spread out or it's localized somewhere, but it obeys an equation, the Schrodinger equation. So far so good, just like regular physics. There's a thing, the wave function, it obeys an equation, the Schrodinger equation. You can predict what's going to happen next. But the weird thing about quantum mechanics is that there's a whole separate set of rules for what happens when you look at the thing, when you observe it, when you measure it.
That's where things get squirrely.
Yes.
With people describing it, right?
Yes.
And that's where they want to go woo-woo on you.
The rules say when the system is observed, when it is measured, its state, its wave function changes dramatically, suddenly, and unpredictably.
Now, let me ask you this. How do we know this based on if you're measuring it and it changes? How do we know? Because we didn't measure it before. Like, what observations are we making that we understand the state of it before it's measured without measuring it?
Good. There's a couple of ways. So let me make things even simpler. Forget about where the electron is located and think about the electron is spinning, right? The electron is spinning just like the Earth spins. It's really exactly like that. It's like a little spinning top, except when you measure the spin, you can sort of send the electron through a magnetic field and it will get deflected either up or down, depending on whether it's spin up or spin down. You only ever get one of two answers. It's either going up or going down. It's nowhere in between. This is an empirical measured fact, okay? So that's a part of quantum mechanics. That's the quantum fact, that there's discrete set of possible answers to this question. Is it spinning clockwise or counterclockwise? Yes or no. It's just those two possibilities, nowhere in between. So if you have a magnetic field that is oriented vertically, send your electron through it, it gets deflected up, you say, oh, it's spin up. So now I've measured its spin. Now I know what its state is. If I send it through another magnetic field, or oriented vertically, it will always be deflected up every single time. We know what it is, we're going to measure it. Measuring it in this case doesn't change it. It's in exactly that state, we know it, okay?